density is mass over volume. Now, the volume of a nucleus, if you assume this as a sphere, will be 4 over 3 pi r cubed. Now, this r is the radius of the nucleus. So, what's the mass of a nucleus? The mass of a nucleus is the number of protons and neutrons in total, which is the mass number, capital A, multiplied by the average mass of a nucleus. Let's call it m nucleon. Now, if you remember the formula for the nuclear radius, capital R, is R naught A to the power of the third. Now, I can substitute this for R in the 4 over 3 pi r cubed. So let's see what we get. So we get A multiplied by the mass of a nucleon divided by 4 over 3 pi r is R naught A to the power of the third cubed. A times m nucleon divided by 4 over 3 pi R naught cubed, yeah, and A to the power of the third cubed is simply A. Now you can see this capital A at the top and bottom gets cancelled out. So that gives us the formula for the density. So density is equal to 3 times m nucleon. So this division 3 I can bring to the top over 4 pi R naught cubed. Now you can see the importance of this formula. So density is 3 constant, mass of a nucleon constant, 4 pi R naught, they're all constants. So the density of a nucleus is constant. You can get this in the exam to derive. So pause the video and quickly jot this down. And let's see what this constant value is, because these are all constants. You can just plug the values in and we can calculate the density of nuclear material. 3 times 1.661 times 10 to the power of negative 27 divided by 4 pi times the value of R naught, 1.05 times 10 to the power of negative 15 cubed. When you put it in the calculator, you get 3.4 times 10 to the power of 17 kilograms per meter. Now, this is an extremely large value compared to the everyday material. So, what's the density of water? Density of water is 1000 kilograms per cubic meter into the power of 3 region. What's the density of iron? Close to 8000 into the power of 3 region. Density of mercury, 13,600. That's 10 to the power of 4 region. And look at this one. So here are some important points you need to know for A-level physics. The density of a nucleus is uniform and it's unaffected by the radius. You can see there's no radius in the formula. Now, the next thing is the uniformity implies that the nucleons are evenly distributed throughout the nucleus regardless of its size. That's why for any given volume, it's the same mass or constant density. Now, the last part you need to know about this is that nuclear density is much greater than the atomic density. And we did the calculation earlier. We got 10 to the power of 17 region. So most of an atom's mass is concentrated in the nucleus. And the nucleus occupies a very small volume compared to the entire atom. But that's why it has to be extremely high in density. An atom consists mostly of empty space.